Okay, folks, this is all about simple machines. Okay, now, have you ever wondered how, say, back in the old, in ancient times, our friend the Egyptians were able to build huge stone pyramids without the benefit of cranes and motors and things like that? Or, for instance, how, with the turn of a wrist, and using what's known as a screw jack, and you've seen this in your car if Dad's ever changed a tyre, you're able to lift an entire car off the ground just by using the force of your wrist. Now, if you were to try and lift that car up, you wouldn't be able to do it. This magic machine, which is a simple machine utilising a screw, which is one of our simple machines that's on the list, you're able to lift tons and tons and tons very, very easily. Okay, so we've got levers. A lever could be something as simple as, you're trying to lift a heavy weight here and you apply a force here and it lifts the weight up that way, okay? So that's a lever, and when you make your effort arm longer, it makes it easier. We'll talk about that later. Wheels and axles, we know how they work. You overcome friction, you make your life a lot easier. Pulleys, okay? A block and tackle set, you can lift an engine out of a car body very, very easily that weighs, tons. No problem at all using a block and tackle system. And it all seems very magical, and gears and chain drives and whatnot. We'll talk about all of these types of simple machines, but it seems like, it's almost like you're creating energy. And of course, that is the wrong way to think about it, because you cannot create energy, okay? Contrary to what you see on the internet, there's no such thing as free energy. So stop thinking about it that way. You need to know a really basic formula from physics, and that is work equals force times distance. And it's measured in, work is measured in units of energy, and the unit of energy is the joule, okay? And now we know our force is equal to newtons, named after Isaac Newton, and distance, of course, we measure in meters. So when we multiply our newtons by our meters, we get a unit of energy, or a measurement of energy, which is telling us how much work is done. So it might help to have a definition of what energy is here too. Energy is the capacity of a body to do work, okay? So you might want to pause your screen right now and write down that information, and we can write that formula as work equals force times d, force times distance. You'll sometimes see that written as F times S in physics textbooks, because S is technically the correct term to use as displacement, which is distance, but it's in a given direction, it says a vector. But let's not worry about that. For the benefit of the problems we're going to do, force times distance is what we need to know. Now, if you have a certain amount of energy that you can expend, you might be saying, well, if I only got a minimum amount of energy, how is it that I can lift that car? Well, when you lift that car, you're doing work. You're providing a force, and you're moving the car over a distance. Okay, so what we need to do is we need to look at some equations that utilize this work equals force times distance. So what I'll do is I will rub out our list, and I'm hoping you've written it down, of simple machines, and we'll just do a few examples. Okay, so what will happen is, if I want to apply a smaller force for a given amount of energy that I've got, I just have to do work that requires, so I needed to do work that requires 100 joules of energy, okay? You've only got 100 joules to work with, okay? That's our work, okay? It's going to be equal to a force times a distance. So that 100 joules is going to be equal to a value of force and a value of distance, okay? So say I can only apply on the jack of my car 1 Newton of force, okay? I'm going to have to move my machine 100 meters, because 1 times 100 equals 100 joules. Okay, now if I could apply 100 newtons of force, I could go 100 times, I don't have to move it 1 meter, okay? But I can't always apply 100 newtons of force. That's way too much force for me to apply. So you might be saying, well, God, how am I going to move the car if I'm applying 1 Newton of force? How am I going to move it 100 meters? That means like, well, I have to lift it 100 meters in the air. Like, that doesn't make sense, okay? So it's a little bit confusing, but the way these simple machines work, for instance, we're talking about a ramp being an easy way of overcoming the forces and using a smaller force to do work. Well, a screw, which is what's happening in the screw jack type of jack that's used on a car, where as you wind it, that's the bottom of our wheel here, tyre. As you wind this lever around, the screw pushes this up, okay? And you might be saying, well, how is that moving at a greater distance? Well, if you think about a screw, if you think about an inclined plane, which we just talked about as a simple machine, a screw, if you can imagine if we had a round object, okay, and we took a ramp and we just went around and around and around and around and around, if you unwound that ramp, it would be very, very long, wouldn't it? Okay, and that's how a screw works. A screw is just a ramp that's been wound around a round object. Okay, so that is how the screw jack's actually working. So you're actually moving it a much greater distance, and because with our formula, work equals force times distance, because the distance is so large, we can do the same amount of work with less of a force. And that's how simple machines work, okay? We're not creating energy, we're just basically able to apply a smaller amount of force, but we just move it a greater distance. So it's not magic, it's pure physics. See you in the next video.